Hello, welcome to our pre-calculus. Topic today is factoring to find solutions in an interval for a trigonometric equation involving sine or cosine. Another way of describing the topic today is mixing quadratic equations with trig equations. That's what we are after. If you look at the first example we are investigating today, you see that it looks like a quadratic equation. 2 times a unknown quantity squared plus 3 times that quantity plus 1 equal to 0. The quantity itself is sine or cosine of an unknown angle. So how do we approach this? Easiest way is perhaps to think about substitution. Let's go ahead think that sine of x, we rename it a, and of course sine square of x will be a squared. So our equation reads like 2a squared plus 3a plus 1 equal to 0. So that's a quadratic equation. We had a short review of equations. We talked about quadratic equations there. So you have several choices here. One is to factor, another one is to use quadratic formula. Whatever applies to your case, you might do that here. It looks like factorization will be easiest for us to consider in this case. I need to have a 2a and an a in my factors, of course, to make 2a squared. 1, well, there's only one way to break that, 1 and 1, or of course minus 1 and minus 1. We check that 1 and 1 works. So I have 2a squared and a 1. 2a times 1 plus a times 1 adds up to 3a. So this is the correct factorization. Now we apply the zero factor theorem. Either 2a plus 1 is 0 or a plus 1 is 0. That tells us a is minus 1/2 or a is minus 1. Well, the question itself didn't have anything to do with a. This was our own convenience to convert it to a quadratic formula and quadratic equation, solve that. So we have to go back to the original. That is, a is sine of x. So either sine of x is equal to minus 1/2 or sine of x is equal to minus 1. So we are going to solve these two equations in the style that we learned in the previous sections. Find the solutions from 0 to 2 pi and see what is so sine of x is equal to minus 1/2. Let's see if we can quickly refresh our memory as to what the story is. So this was the sine axis. We go ahead and find out where minus 1/2 is on that. Minus 1/2, we draw a horizontal line, and these two angles. So here's an angle, and here is the other one. What are they? So they are going to be x is equal to pi plus pi 6. That is 7 pi 6. And the other one is 2 pi minus pi 6. And that would be 11 pi 6. Or look up in your table or look up in your unit circle. The other one, sine of x is equal to minus 1. Sine of x is equal to minus 1. And minus 1 is right here. So x is going to be one angle shows up, and that is 3 pi over 2. 3 pi over 2. So on Alex, we are going to record 7 pi 6. 3 pi over 2, 11 pi 6. Correctly spoken, this is a double root. That is, there are two numbers just like these two that have merged on top of each other and make 3 pi over 2. But in Alex, just count it once, and that is your answer. Same thing applies to all the other problems in this section. Again, remember that we are looking at 0 to 2 pi. If you want all the other ones, then you have to add 2k pi to all of these. Here's another example. So again, we go ahead and take a to be cosine of theta, and then of course a squared means cosine square of theta, and the equation that we are having is a squared plus 2a minus 3 equal to 0. So a plus 3 times a minus 1. By trial and error you find these. Double check. 3a minus a makes 2a, and then we have either the first factor sorry, a plus 3 is equal to 0, or a minus 1 is equal to 0. The first one says a is minus 3, and second one says a is equal to 1. Now again, a wasn't a object to be found. It's not referred to in the original equation. It's the theta we are after. So we go back to either cosine of theta is equal to minus 3 or cosine of theta is equal to 1. Well, what do you think? Cosine of theta equal to minus 3. Is there such an angle? Cosine is between 1 and minus 1. It never becomes minus 3. Here, to refresh our memory, again we draw the unit circle. Cosine of, so if they had given me 1/2, I would have gone up and down and say these are my angles. But that's not what's showing up here. It's minus 1, minus 2, minus 3. If I draw a vertical line and minus 3, it doesn't cut the circle. So this one simply has no solution. Cosine of theta equal to 1, well, theta is equal to 0. Is the angle at which 0 is right here, 0. And remember, 2 pi is not acceptable, so the only final answer that we have is just 0. There's nothing else. So this branch, this was a dead end. It didn't give us anything. And the other one just gave one answer. Okay. Next, this one, we take sine of x to be a, and then of course sine square of x is a squared, and then I have 2a squared minus 7a minus 4 equal to 0. So again, several choices. You can do by trial and error, you can do by quadratic formula, you can do by factoring into terms. Let's try all of them. So for the a squared, the only way to get to a squared is having 2a and a. So that's a blessing that there are not any other choices. If that number was much bigger, like it was 24, we would be really in trouble because there are just so many choices. Here, it's not that bad. 4. I can have minus 4 and 1. I can have minus 2 and 2. I can have minus 1 and 4. I can have, going the other way, 1 and minus 4, 2 and minus 2. I can have, of course, 4 and minus 1. Which one of them is it that when I multiply by 2 and 1 and add them, it's going to give me minus 7a? Sorry. So it's obvious that this one is our favorite, because when I say minus 4 times 2, I will have minus 8, and plus 1a gives me a total of minus 7a. Okay, so we wrote out how many ways you can factor minus 4. There were 6 different ways of it. Which one of them will give us the middle term? That's the only one. So I have 2a plus 1 is equal to 0, or a minus 4 is equal to 0. One of them. So either a is minus 1 half, or a is equal to 4. Just like that line, sine or cosine don't exceed 1, so this one is a dead end. It has no contribution to our set of solutions. And this one, if I write sine of x is equal to minus 1 half, we just saw that x has to be 7 pi 6 or 11 pi 6, and that's the only answer that we have in this case. Now we said let's do it other styles as well. Other style would be what? 2a squared minus 7a minus 4. What if our factorization, there was trial and error, was much lengthier, or perhaps it wasn't such nice numbers. Perhaps the factorization doesn't give you whole numbers all the time. So what do? It says, okay, a is minus middle term, so minus 7 plus or minus middle term squared, minus 7 squared, minus 4 times first and last numbers, divided by twice the first number. Is that right? So if you have ax squared plus bx plus c equal to 0, quadratic formula, minus b plus or minus b squared minus 4ac divided by 2a, something you have practiced plenty in your prior classes. So here that's what we are using. So it's 7 plus or minus, it's 49. This becomes 32 plus over 4. So a becomes 7 plus or minus radical, it's 81 over 4. The 7 plus or minus 9 over 4. And two choices, either 16 over 4, which is that 4 that we had here, or 7 minus 9 over 4, that's minus 2 over 4, or that's minus a half, and that's the other solution we had. So this one again just leads to the same answer that we had before, minus a half. The angle has to be 7 pi 6 or 11 pi 6. So that's another style in case our trial and error factorization didn't pan out that easily. That is the fallback position that works every time. So this is like the beacon. Any problem you can approach it this way. You can apply the quadratic formula. Well, any other way? How about this a little bit made easier? So again, here is 2a squared minus 7a minus 4 equal to 0. Perhaps your high school teacher told you to do the following. Take the first and last numbers and multiply them. So 2 times minus 4 is minus 8. And this one also is just minus 7. Find two numbers such that their sum is minus 7 and the product is minus 8. Product is minus 8 and the sum is minus 7. Of course, these two numbers are just minus 8 and 1. These two numbers, if you multiply them, you get minus 8. You add them, you get minus 7. Okay, now what? We say the following: 2a squared minus 7a minus 4. Take this minus 7 and write it as a sum of two such things. So 2a squared minus 8a plus 1a. This is just another way of writing minus 7a. Now, why would you do that? Because the first two and the last two can be factored. How do you factor this one? You say, I can factor 2a times a minus 4. How about these two? Well, there's nothing to factor. It's 1 times a minus 4. Now, a minus 4 is common. That is what makes this magic work. A minus 4 is common, and you get 2a plus 1 as your other factor. So you have achieved the factorization. So this whole thing was, how do you do the factorization when the coefficient is something other than 1? Out of this you get either a is minus a half or a is equal to 4, which is what we had previously, and then you arrive at the same answer. So this becomes a dead end, and all that you have is 7 pi 6 and 11 pi 6. From this solution you get these answers. Okay, lengthy title, we said it means you have a quadratic equation where your unknown quantity is sine or cosine of a certain angle. Okay, hopefully these are easy for you to do, or we are going to see again. Until then, good luck and God bless.